This is pre-algebra lesson 1-8. Look for a pattern. Many types of problems can be solved by finding and using patterns. Making predictions from patterns is a form of inductive reasoning. Let's look at this problem. News spreads quickly at Riverdale High. Each student who hears a story repeats it 15 minutes later to two students who have not yet heard it, and then tells no one else. Suppose one student hears some news at 8 a.m. How many students will know the news at 9 a.m.? Okay, so let's take a look at this. I kind of like to organize my information, so I'm going to organize it into a little bit of a table here. Okay, so we start at 8, end at 9, and they're told in 15-minute increments. Okay, start at 8. 8 a.m. end at 9 a.m. 15-minute increments, which means 4 15-minute intervals. Four 15-minute intervals in 1 hour. So that's my pertinent or importance information. So let's think about this. So let's do the time as being 8 a.m., 8:15, 8:30, 8:45, and then 9. Number of new people, and then number of total. So let's write down the table here. All right, so at 8 a.m., it says, suppose one student hears the news at 8 a.m. So at 8 a.m., one person knows the news. The total number of people is 1. At 8:15, that person tells 2 new people. So there's now a total of 1 plus 2, or 3 people that know the story. At 8:30, those 2 people tell 2 other people. So these 2 people each tell 2 more people, so now there are 4 new people that know the story. Okay? So how many people know the story total? Well, there was 3 who knew it, now there's 4 more who know it, so now 7 people know the story. At 8:45, those 4 people each tell 2 people. 4 times 2 is 8, so 8 new people know the story, and 7 plus 8 equals 15 total people. At 9 a.m., those 8 people tell 2 new people each. 8 times 2 is 16, so there are 16 new people that know the story. And 15 plus 16 means that there are 31 students who know that story. So in 1 hour, 31 students know the story. Okay? So how many students will know the news at 9 a.m.? 31 students will know the news. And this is just one way of setting up this problem. Okay, I'm an organizer freak, so I kind of like things neat and tidy and organized. So this table was one nice and neat way of doing it. But it's not the only way. Okay, we could have used a tree diagram. Okay, it's a bit more visual, takes up more space, but it would look something like this. Okay, at the start, okay, at 8 a.m., here's my start at 8 a.m. Okay, that person tells 2 people. Okay, so at 8:15, 2 people know the story. Okay. Each one of those 2 people tells 2 people more at 8:30. So at 8:30, we have this many people. And then those 2 people each tell 2 people. This person tells 2, this person tells 2, this person tells 2, this person tells 2. So at 8:45, we have 1, 2, 3, 4, 5, 6, 7, 8 people that know the story. And each one of those people tells 2 people. This one, 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 and 2 from this one. So by 9 a.m., okay, you have 16 new people, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So there were 16 new people here, there were 8 new people here, there were 4 new people here, there were 2 new people here, and there was 1 new person here. So if you add all those up, 16 plus 8 plus 4 plus 2 plus 1, okay, you're going to get 31 people. So that's just a different way of looking at the exact same problem. If you're a very visual learner, this might be more helpful for you. You just have to remember that these are just the new people that learn the story each time. So then you have to add all these together when you're done. It's very visual. All right, let's take a look at the same problem. There are 251 students at Riverdale High. By what time will every student know the news? Okay. So if we look, if you remember the table, every 15 minutes, the number doubles the previous number. Or we can even look at this, every 15 minutes, this doubles. 1 times 2 is 2, 3 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So it doubles every 15 minutes. Okay? So at 8 a.m., okay, 8 a.m. one person is going to use 8:15, 9, 8:30, 8:45, 9, 9:15, 9:30, 9:45, 10. Okay, and we keep going. So, okay, at 8 a.m. one person knew it. 8:15, 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16 new people knew it. Okay. Okay, so then we got 16 times 2 is 32 new people. 32 times 2 is 64 new people. 64 times 2 is 128. And then 256, but there's only 251 students, so I don't think we need this last one. Okay, so if we add all these up, 1 plus 2 plus 4 plus 8 plus 16 plus 32 plus 64 plus 128. And if we add all these numbers up, okay, let's see here. This is 10. That's 10. That's 20. That's 30. So, and let's see here. These two numbers here. So 60. And so we have 160 plus 20 plus 10 plus 65. Okay. That's 190 plus 65, which is 255, which is greater than 251. So by 9:45 then, okay, by 9:45, everybody in the school is going to know. Okay, because at 9:45, 255 students do the story. So by 9:45, all students will know the story. I do not want to go to that school because, heaven forbid, you can't keep a secret there. Let's take a look at another problem. Each student on a committee of 5 students shakes hands with every other committee member. How many handshakes will there be enough? Now this one can be very, very confusing if you don't think of pictures. I'm a picture person, and I can't draw, so I'm a stick and a dot or stick figure type person. Let's take a look at this. Each student on a committee of 5 students, so we have 5 students. 1, 2, 3, 4, 5. They shake hands with every other student. So let's take student 1 here. Student 1 is going to shake hands with this student, and this student, and this student, and this student. Once they're done, nobody else is going to shake student 1's hand because they've already shaken everybody else's hand. So let's think of this. Let's think of the students as being dots. If there is only one student at the committee, there are no handshakes, aren't there? Okay? There's just one little student, there are no handshakes. Okay, I'm going to represent the students by dots now. Okay? 0 handshakes. If there are 2 students, then those 2 students, there's only going to be 1 handshake. If there are 3 students, okay, if there are only 3 students, let's think of this way. These 3 people, he's going to shake with him, And then this guy here is going to shake with him. So there's going to be 3 handshakes because they don't need to shake hands with student number 1 because they already have shaking hands with student number 1. So he's going to shake with him, he's going to shake with him, and he's going to shake with him. So there's 3 handshakes. If there are 4 students, 1, 2, 3, 4, and then this person will take this person. So that's 6 handshakes. Okay? And last but not least, 1, 2, 3, 4, 5. 1 handshake, 2 handshakes, 3 handshakes, 4 handshakes, 5 handshakes, 6 handshakes, 7 handshakes, 8 handshakes, 9 handshakes, 10 handshakes. Okay. If we made a little table here, same problem. And how many handshakes will there be with 5 people? There'll be 10 handshakes. If I made a little table, number of students, and then handshakes, you might be able to see a pattern. And that's the reason. If there's 1 student, there was 0 handshakes. 2 students, there was 1 handshake. 3 students was 3 handshakes. 4 students was 6 handshakes, and 5 students was 10 handshakes. So let's take a look at my little table here. As the number of students went up by 1, what did this happen? This is plus 1, this is plus 2, this is plus 3, this is plus 4. So you can continue on going, this is going to be plus 5, and then plus 6, and etc., etc. When you get to Algebra 1 and Geometry, we're going to show you how to solve this table even further without having to actually do, because I could actually ask you how many handshakes will there be if there's 100 people in the room. You're not going to want to have to do a table out to 99 people to figure out the handshakes. But for right now, we're going to stay fairly low, and this is how you look for a pattern. 2 different ways of looking at problems and solving them in different ways.